You know that box that sits in pretty much every kitchen, the one that seems to do actual magic. You put cold food in, you push a few buttons, and a minute later, it's piping hot. No fire, no glowing red coils, just a hum. Well, today we're going to pull back the curtain on this everyday miracle, the microwave oven.
A great question, isn't it? I mean, it seems to defy all logic. But here's the thing, it's not magic at all. It's just really, really brilliant engineering. So let's open up this box together and find out the incredible physics that make the whole thing work.
Okay, first things first. We have to get one huge misconception out of the way. A microwave oven doesn't create heat like a regular oven does. It creates energy.
Think about it this way. Your regular oven is kind of like a campfire, right? It heats up the air around your food, and that heat slowly cooks it from the outside in. A microwave, though, it completely skips that step. It shoots energy directly into the food itself, heating it up from the inside. It's just a completely different way of getting the job done.
So what exactly is this energy? Well, it comes in the form of, you guessed it, microwaves. And get this, they're part of the exact same electromagnetic family as the radio waves that bring music to your car. They're just tuned to a very, very specific frequency. A frequency that happens to be perfect for getting one particular molecule to party: water.
All right, so if the oven is using microwaves to cook, where do they actually come from? Well, inside every single microwave is a kind of engine room, a single part that generates all that cooking power.
And here it is, the Magnetron. This thing is the absolute heart of the machine. It's a powerful vacuum tube that takes the regular old electricity from your wall outlet and transforms it into the invisible cooking power of microwaves.
So how does this clever little device work? It's basically a four-step dance. First, it uses electricity to generate a bunch of electrons. Second, a powerful magnet makes all those electrons swirl around in a circle. Third, and this is the amazing part, as those electrons swirl, they radiate energy as microwaves. And finally, a little antenna grabs those waves, and a channel called a waveguide shoots them right into your oven. Simple, but totally brilliant.
Okay, so we know what microwaves are, and we know where they come from. But how do they actually cook your food? This is where it gets really cool. It all comes down to a tiny dance happening inside your dinner.
You see, the secret ingredient in all this is water. Water molecules are something called polar. All that really means is you can think of them as tiny microscopic magnets, each one with a little positive end and a negative end. And that simple fact is the key to everything.
So when the microwaves hit your food, their electric field starts flipping back and forth at an insane speed. And since those water molecules are like little magnets, they try desperately to line up with that field. The result? They start flipping back and forth over and over, billions of times every single second. It's a truly frantic molecular dance party.
And all that frantic flipping creates a massive amount of friction as the molecules bump into each other. And what does friction create? That's right, heat. This is the core idea. The microwaves themselves aren't hot at all. The heat is actually generated inside the food by all those water molecules rubbing together. The fancy scientific name for this is dielectric heating.
And this explains so much, right? It's why a bowl of soup or some vegetables get piping hot in just a minute, but a dry piece of bread just gets a little warm and kind of soggy. It's all about the water content. The more water, the more molecules are dancing, which means more friction and a whole lot more heat.
But using waves to cook food creates a big engineering challenge. See, if you just blast microwaves into a metal box, you don't get even cooking. You get some parts that are scalding hot and other parts that are still cold. So the engineers had to get clever.
Exactly. Just like waves in the ocean, microwaves have peaks where there's a lot of energy and troughs where there's not much at all. If your food just sat still, it would cook completely unevenly. So how did they fix this fundamental problem?
Well, they came up with two main solutions. The one you probably know is the turntable. It's a simple fix. It just rotates the food through those fixed hot and cold spots, making sure every part gets a turn in the energy beam. Some other ovens, especially built-in ones, use a hidden stirrer fan. It's basically a metal blade that spins and bounces the microwaves all around the oven randomly, which evens things out.
All right, for our last section, let's tackle the one rule that absolutely everybody knows, even if they don't know why. You never, ever put metal in the microwave.
It's the classic warning.
right? We've all been told 1,000 times. But what's actually going on in there? Why is putting a metal fork in so dangerous, but a ceramic bowl is totally fine? Let's break it down.
Okay, here is the critical difference. Your food absorbs microwaves, but metal conducts electricity. When microwaves hit a piece of metal, they create strong electric currents that race across its surface. Now, on a smooth piece of metal, this isn't a huge deal. But on thin or sharp points, like the prongs of a fork, those electric currents get concentrated. They build up a massive charge with nowhere to go, so it arcs through the air to the nearest bit of metal. And that's when you see those big, dangerous sparks.
So when you really step back and look at it, the humble microwave isn't just a simple hotbox. It's a masterpiece of applied physics. It takes these abstract ideas like electromagnetic waves and molecular polarity and harnesses them to create a tool that has literally changed the way we eat and live. It's truly brilliant engineering hiding in plain sight.
And that kind of leaves us with one last question to think about. Now that you know the secret of the microwave, what other magical devices in your home are just waiting to be understood? If you look around, you might be surprised by just how much genius is hiding in the everyday things we take for granted.
Thanks for joining me.